Hello and welcome to the next episode of the Klingberg Wing Mark II development. I'm Klingberg, your host. Today we're going to have an interesting little topic, going to try to keep it short, about confirmation bias. And for those of you who aren't familiar with that term, stick around and watch the rest of the video. Here we go. Okay, welcome back. So, confirmation bias. It's a basic psychological principle that says we tend to accept those results which we expect. When the data comes out the way that we expected it to come out, we go, oh, that's good data, and we write it down. We collect that data. And sometimes when we're doing research work and we get data that is not what we expected, we go, oh, bad data. I'm not wrong. The data's wrong. Something went wrong with the experiment, and we throw it out. And quite often, the data's correct. So when you do research work like this, you have to be really careful not to have confirmation bias. You must be prepared for unusual results. And I had those the other day, and I was not prepared for them. But I am quite familiar with confirmation bias, having suffered from it many times, as any person would. And when it hit me in the face, I just had to laugh. I'm out here in the garage early in the morning, and I'm working on some samples, and I get an unusual result. And I just started laughing. It's like, oh my gosh, the irony, just the ludicrous nature of the results. It's like, but that's the results. It has to be true. Double check, remeasure. Yeah, it's true. Have to accept it. Write it down. And it's changing everything. That happens sometimes. You get results that change what you're doing. And you have to be prepared for that, especially when the change is for the good. Now, as you know, if you've been following along, I've had a bit of a problem with doing the D-tubes, which you see behind me, in the long length, the 18.5 feet long. There's been a variety of issues. We knew it was going to be a big challenge going in, didn't know how the problems were going to be solved, and just thought I'd work my way through it. And that's what I've been doing. And then I ran into these unexpected results. And as you know, the big problem's been with this Mylar covering, and I don't know if you can see it in the video here, but I use this Mylar on the outer surface when I mold the outer surface to create a nice smooth finish for the airfoil. And as we all know, smooth is better when it comes to airfoils. Now, better doesn't necessarily mean necessary. We could use the two ends. Smooth is nice, but not necessary in all cases. In fact, the question becomes, how smooth? How smooth does it have to be? When you have laminar flow airfoils, smooth is critical. Smooth goes from being nice to necessary. But I'm not using laminar flow airfoils. I'm using all NACA sections. And smooth is nice, but not necessary. It can be a little bit rough, and no change in performance, because at 1/3 chord, the boundary layer is going turbulent anyway. The way that this airfoil is set up is the camber is far forward in the airfoil. So you get a quick camber up front, and then you get into the pressure recovery. So quite rapidly, this airfoil, rapidly in terms of chord length, the airfoil goes into a turbulent boundary layer. And once you're there into a turbulent boundary layer, well, the surface finish doesn't matter. There's almost no impact. So the aft portion of my wing is just fabric and ribs, just normal construction. The front end, the D-tubes, we want those fairly smooth. Now, on a D-tube, or the front portion of the airfoil, anywhere where the thickness of the airfoil is getting larger, as the airfoil is getting thicker and thicker up front, that's where it's good to have it really smooth, because that is what we call a proverse pressure gradient. The boundary layer is not going to go turbulent when you're in a proverse pressure gradient, but as soon as you switch from proverse to adverse pressure gradient and you get into the pressure recovery, that's when the boundary layer goes turbulent. So on laminar flow airfoils, because such a long distance of the airfoil, like half of the chord, is in a proverse pressure gradient, you have to keep all of that really smooth. And on these old airfoils, not so critical. The less slope there is on the upper surface of the airfoil, the less slope up, the smoother that surface has to be in order to maintain that proverse pressure gradient and not have the flow trip and go turbulent. Well, in this airfoil, it's really steep up front, kind of rounds over, and down she goes. It all happens very fast. So if I keep the most forward portion of the D-tube smooth, the rest of it doesn't matter too much. So I have some stuff I can play with there. So the Mylar is more a convenience thing, sort of. Turned out to not be very convenient, but it was there so that when you peel the Mylar off, you're done. You don't have to go back and sand and finish and do all this other labor. You have a ready-to-go finished surface, and you can either paint it, put covering on it, whatever you want to do, but it's smooth enough. Not as smooth as female molds, but good enough. Yet the Mylar was problematic. Wrinkles, causing all kinds of problems, handling problems, you name it, we've run into them. So while we were working last time, my buddy Bob says, Raul, what if we use the Stretch-A-Lon material, that really stretchy vacuum bag stuff you have, and we use that as the outer surface rather than the Mylar? And I says, Bob, I've tried it. It leaves a really wavy surface. It's not smooth. It's not rigid enough. And he went, oh yeah, that makes sense. So okay. And I says, I'm going to try some other stuff, and we'll see where we end up. And if you watched the previous video, you know one of those items I'm looking at is post-molding to go back and fill the surface and sand it smooth and then cover it, which is more labor. And labor, and when I say more labor, I'm talking 2 to 4 days of labor, a lot of work. So here I am. Here's a sample that I did before, and I'll tilt this and we'll see if we can pick up some of the studio lights here. There we go. It's being nice and reflective. You can see this is a really smooth surface. And you can put covering over this, you're done, you're good to go. This is 3.6 ounce fabric on the outside, which is what I'm using on the D-tubes. And this had some 4 ounce carbon fiber on the inside, and the Aerex foam is the 16th inch thick stuff, really thin. And this came out to weigh 1.83 ounces per square foot. 1 ounce on the aircraft translates to 8 3/4 pounds for the entire surface of the wing. For just the D-tubes, it's a third of that. So if this is 9 pounds, 1 ounce translates into 3 pounds of weight. For every ounce that we add or remove, we add or remove 3 pounds for the D-tube. So if it weighs 2.83 ounces, well, that's 3 pounds heavier for the entire aircraft. That's significant. But I've got a nice smooth surface, comes out of the mold, it's ready to use. So I'm going to run some variations based on some of the problems that we're having and see, is there an alternate path, an alternate way out of this problem? So what I did is, because my buddy Bob's a really smart guy, like me, he doesn't know everything, but he's pretty smart and he thinks his way through stuff. So I'll try the Stretch-A-Lon material as the outer baggy material, and I'll see if I can squeegee it out smooth and get all the wrinkles out of it. And for a small panel, I was able to do that. And that generated this panel here. And you'll see that it's somewhat reflective, but it's not smooth. This is rough to your hands. Not rough as in sharp, but rough as in bumpy. It's as smooth as plastic, but it's got a lot of little tiny variations in it. Little itty-bitty ones. 10 thousandths, 20 thousandths, something like that. And you can see the fabric, the 120 style fiberglass fabric has printed through. And there's a little bit of roughness from the fabric there on that. And a seam that I did here, I'm testing the seam has disappeared. The seam is gone, so that's good. So now this is done on 3/32 inch Aerex foam with 4 ounce carbon fiber on the inside. So it's the same as this one over here, but it's a little thicker. 3/32 is what I'm using on these main panels. And I need that extra thickness for a little more stiffness in the D-tube. So this came out to be, same fiberglass on the outside. This came out to weigh 2.76 ounces per square foot. That's almost an ounce more than this. So these D-tubes, compared to using this material, are going to weigh 3 pounds more. Actually, it comes out to be about 2.5 pounds, 2 1/4 pounds more. And most of that, believe it or not, is the foam. That extra 1/32 of an inch of foam spread over that large D-tube area adds up in a hurry, and it adds weight. Because the fiberglass is the same, carbon fiber is the same. Now, this fiberglass is a little bit different. This fiberglass had the Mylar finish on it, squeezes out all the extra epoxy, makes it nice and flat and smooth. This one gets bumpy. You know, the waviness that's in the plastic, there's resin sitting in that waviness. So it's a little heavier, but mostly it's the foam. And you say, Raul, make the foam thinner. Well, I can't. I need the buckling length. I need to have a longer buckling length. If I made this foam thinner, I'd have to put in more nose ribs, and we'd end up right back where we were before. So it's just easier to build it with fewer nose ribs and go a slightly thicker D-tube that will resist the local buckling. So there's that one that I did. Now I did another one that involved wet out the fabric. Oh, all of these were done the same way with this outer layer of fabric. Wet out the fabric separately, lift it off the plastic sheet, put it on the foam, squeegee it out, and this one was vacuum bagged. This one, done the same way, wet out the fabric, bring it onto the sheet that I'm forming, and squeegee it out. And this one I put peel ply over, because the peel ply will give a consistent height for the variations in the resin. You know, it's the thickness of the fabric and the weave and all of that other stuff. Very easy to fill or sand or whatever, because it's even everywhere. It gives a nice even surface. Well, an unexpected result. And there it was. But in this case, an undesirable unexpected result. And when you have unexpected results that don't meet your thinking of what's going to happen, and they're bad, well, it's real easy to throw them out. You throw them out, you go, oh, bad result, throw it out. So I did. And what happened here is that this was not vacuum bagged. This was just a wet layup on here, squeegeed out. And the peel ply soaked up the epoxy out of the fiberglass as it went through its cure. And there wasn't enough epoxy left to bond it to the foam. And this outer layer is not bonded to the foam very well, is it? Not very good at all. This is a really bad answer. And this weighs, what did this come out to be? 2.64 ounces per square foot. And this is 2.76. So this was only ever so slightly lighter, 1/10 of an ounce per square foot lighter than this one. So not a big difference in terms of weight, but a huge difference in structural integrity. So that one's out. And then I did one, which I have a hard time showing you here because it's on one side of this. This side was the peel ply side, and this side, no peel ply. Wet out the fabric, put it on the foam, squeegee it out. Look for dry spots. Come back with epoxy, wet out the dry spots, and keep squeegeeing until the fabric is even everywhere. And looking for glossy areas. See a glossy area, spread out that resin. No extra resin as far as the eye can see. And let it cure. This is how I did my original wing. And you do get an excellent bond of the fiberglass to the foam, but you get a pretty rough outer surface. This both has variations in it, and it has roughness of the fabric sticking up. The little itty bitty microscopic fibers that are loose in the fiberglass actually end up sticking up like this, and epoxy forms little fillets around them. You get a pretty rough surface. So this is viable, but this surface is even too rough for a D-tube. On my original wing, we didn't care that much. It wasn't going to be a driver. We were not in that performance range. But for this glider, this is critical, and this rough D-tube surface would be a significant ding on performance. So then it became a question of, what does it take to fill these two surfaces? That one's out. So we have these two, okay? And how much of this filler, I showed you this glazing putty from the auto industry in another video. How much of this glazing putty does it take to fill these surfaces? Well, the putty's not cheap. Surprisingly, as a little aside, once I buy enough of this putty to fill the entire D-tube, it's about a push what the Mylar cost. This Mylar to cover the entire D-tube costs about $40 to do one D-tube, and you use it once and you throw it away. So that's $40 that goes in the trash can. And it's going to take about $40 of glazing compound to coat one of these. So the cost is about a push. So I'm okay with that. So in order to reduce the usage of this, so I don't need as much glazing compound, I thought I could come in and sand these surfaces initially to take off some of the high spots. And I sanded very, very carefully so as not to sand the fabric, just the resin. The extra resin and the microfibers that are sticking up here don't do anything for structural integrity. And the waviness that's in the resin here because of the plastic, it's not doing anything for structural integrity. As a matter of fact, when we stop to think about it, this really nice, shiny, smooth surface on this guy, that shiny, smooth surface is at the cost of weight. There's resin that is sitting on top of the fabric here. It was between the fabric and the mylar, and it's the resin that's forming this really smooth surface, but it doesn't add to structural integrity. It's just providing a finished surface. So it's additional weight in terms of structural strength, but it's serving the purpose of surface finish. And the question becomes, how expensive is it in terms of weight to get that surface finish? And if I'm going to put a covering over it anyway, well, that's even more weight. Interesting. Okay, so I went and sanded these, sanded them out, and that's these two samples over here. Okay, so this is the one with the Stretch-A-Lon plastic vacuum bag over it, and this is the one with the somewhat rough but uncovered wet layup finish. And you'll notice a difference right away. This one has a lot more glazing compound. It took, even though I sanded it first, it took a lot more glazing compound to smooth it up. And you can see that right in the surface. This one, not so much. The surface was somewhat smooth to start with. So these were sanded with some like 80 grit initially, just to take off the high spots of the glazing compound, and then I sanded with 220 grit to make it really smooth. And you could actually come back with some like 600 grit wet and make these super smooth. Although I discovered it wasn't necessary. When I put the Oracal covering on these, 220 was fine. There's no need for wet sanding here. Dry sanding with 220 gave me a surface that's nearly as good as that. So here we have this surface that involved the Mylar, and I can produce a highly similar surface just by hand sanding with 220 grit. So I'm out in the morning, out in the garage, and I sand these down, make them nice and smooth, stick these samples of covering on here and go, oh yeah, that's pretty smooth. Maybe I can get them up in the light for you. They're really smooth. Great for a D-tube. Okay, let's find out how much weight was added by putting this glazing compound on here. So now, my original sample of this weighed, let's see, do I have the right one here? Yeah, I have the right one here. This weighed, actually, originally, it weighed 0.88 ounces for this panel. This panel started out at 0.88 ounces. And I throw it on the scale, set my scale to 0, it's a very sensitive scale, plop it on there, I get 0.85. I'm like, what? No, I didn't zero out the scale properly. Take it off. Oh, the scale went back to 0. Well, I can't be right. Turn the scale off. Turn the scale back on again. Put it back on there. 0.85. Again. Lift it off. Put it back. 0.85. 0.85. 0.85. Well, I'll turn it. 0.85. It's like, that can't be. I put this glazing compound on here and sanded it, and it's lighter. I added material, and it got lighter. How's that possible? And that's an unexpected result that goes right straight on and affront to that confirmation bias that I have. My confirmation bias says, if I add material, it's going to get heavier. And then the light bulb went on. I went, ugh. I sanded it first. I took off the extra resin that was on there, extra epoxy resin, put the filler on. The filler is lighter than the resin I took off. And the net was a loss in weight. It's actually lighter. I go, is it a valid result? I took the other panel that had the wet layup, that took a little bit more filler. Took more filler. Close. This was 0.99 starting out, and it came out like 0.97. This took more glazing putty to fill it, but it still weighed less. And that's when I started laughing. I just stood there. I thought, oh my God, I've been doing this stuff for decades, 4 decades, 40 years, maybe more. And here's a result. I thought I knew what I was doing. I had an expected result, and I got a 180-degree the other direction result. Like, holy crap, that can't possibly be true. And I go looking at it, I look some more, and it's like, it's true. And when I thought about it, and then when I talked about it to Bob, and I says, Bob, it started out 0.88 ounces, and now it's 0.85. And he went, what? And the first thing he says, oh, that's a significant number. I go, yes, it is. And then he says, oh, you sanded off resin. I go, yeah, that's exactly what happened. I says, I sanded off epoxy resin, added the filler back on, and the filler was lighter. It's like, holy crap. All of that Mylar stuff, everything else that I've been doing, waste of time, waste of development effort, waste of complexity and difficulty of doing it, waste of materials, waste of the number of different types of materials you have to keep in stock, just insanity. And that's why I had to laugh. Everything that I was doing was home builder insanity. Made no sense, wasn't necessary. I was doing a whole bunch of stuff that wasn't necessary. All I had to do was lay it up, vacuum bag it, sand it when I'm done, fill it, and then resand it. And this doesn't matter because I'm going to put covering over it. You're not going to see the filler anyway. Wow. And I had to accept this as a fact. And then you come down to, it's like, hey, Raul, earlier in the video you said 4 days work. And I go, yeah, it could be 4 days worth of work. By the time you glaze it, top and bottom, maybe an afternoon to do a top, and then you got to do a bottom, because you can't do them both, because you got to flip it over to work on it. So you do one side and then the other side. And you could probably sand it in one day. So at least 3 days to do this job. 3 days to fill and sand. Well, that's a lot of work. But what's labor compared to weight? We know that the driving parameter on this aircraft design is weight. You got to keep the weight down. They're like, is it going to be worth 3 days to save 0.03 ounces for this size panel? And I go and do the calculations for these D-tubes that are right behind me. And you might be surprised that 0.03 ounces for this size panel, when translated to those size D-tubes, 1.5 pounds. 1.5 pounds. That's for the 2 D-tubes. Out of an aircraft weight of 100 pounds, the sanding and filling will save me 1.5 pounds. 1.5% of the empty weight of the aircraft. When Bob said it's a significant number, he wasn't kidding. I will fight tooth and nail to save 4 ounces. 1.5 pounds. Holy smokers. I'll spend 3 days to save 1.5 pounds, and I think most other builders would also. That's 1.5 pounds I don't have to pick up and run with. That's 1.5 pounds I don't have to lug around when I'm assembling the thing. And if I keep saving 1.5 pounds here and there and everywhere, I'm going to get a lighter aircraft. So there you go. Labor versus weight. Build it fast. Build it done quick. Pull it out of the mold. It's ready to go. Weighs more. On a full-size sailplane, it doesn't matter. On this thing, it's all the difference in the world. More labor, reduce the weight, and come out ahead. And when I was laughing at myself out in the shop, my wife had to come out because she doesn't hear that too often out in the shop. Usually hear swearing instead of laughing. And she says, what's going on? And I says, irony. I've been attacked by irony. And yet, I have to accept the fact. Despite all my decades of experience doing this, I got a result that did not confirm my bias. But I have to accept it as being true, and we'll all move forward. And hopefully, you can remember that when you're working on your own projects, that when you get a result that's unexpected and doesn't confirm your bias, stop and think about it, and don't throw out the baby with the bathwater. There might be a hidden gem in there somewhere. So, lesson learned for all of us, and now I can get rid of all that Mylar and all of the accoutrement with it, and we can get going on these darn D-tubes and get them finished, and finish building this thing and go out and test fly it. So that's the good news. And thanks for watching. In the meantime, fly safe. Bye for now.